Hello everyone, and welcome to another episode of Hacking with Friends. Now today we're going to do something that I think is really fun. We're going to explore an old school topic, which is war driving, but with an updated guide. So we're going to be using the fully updated version of Kismet to do some war driving, which is basically geolocating the source of wireless devices and wireless networks around us, so that later we can go back and discover where all of them are, or contribute to a much larger database called Wigle.net. Michael, thank you for joining us today. Michael is our production gremlin and security researcher.
I was about to say I just got promoted from production gremlin
to production gremlin manager and also security researcher.
Yeah.
So
and Kody Kinsey.
And I'm Kody Kinsey. I'm security researcher with Varonis. And today we're going to go through how you, with a Raspberry Pi computer and a wireless network adapter, and also a GPS receiver, can basically map the location of both devices and also networks around you. And this has a number of really cool and really interesting applications. In fact, if you want to see my personal favorite application of this, you should check out the creep detector, which basically uses this setup to detect when someone's device has been close to you in two places that are too far apart to be a coincidence. So it basically means if someone is following you, it enables you to be alerted that, hey, this device was, behind me at the grocery store, it was behind me at the bank, and then it followed me home most of the way too. You would be able to basically mount a Raspberry Pi on a skateboard, skate around, and find out if someone had been following you around while you were going about your day. So
that sounds pretty cool.
Yeah, lots of cool things you can do with this. Fundamentally, what it is doing is it's using the wireless radio to be able to detect anything that's broadcasting over Wi-Fi. So that could be disconnected cell phones that are just going about their daily business looking for a wireless network nearby. It could be computers that are connected to a wireless network, and it could be IoT devices like printers or security cameras that are connected to a wireless access point nearby. So what's cool about this is that Kismet allows for a tremendous amount of signals intelligence. We can also just go ahead and upload this to a huge database of different geolocated access points. And while we aren't going to be able to get into the specifics of individual devices when we do this, because by and large, Wigle.net tracks access points, not individual devices, we can still be able to find out, a lot of really useful information based on this. So let me give you some of my favorite examples of why this information is useful. One of them is most smartphones, when they're in an area that has bad access to actual GPS signals, will fall back on Wi-Fi to figure out where they are. So there's a couple of really cool programs. One of them is called Skyhook, that uses a tiny ESP8266 to broadcast fake networks that make devices nearby think that they are in Zuckerberg's pool.
Wow.
Yeah, so
that's really
somebody
cool.
just figured out the nearby Wi-Fi networks for Mark Zuckerberg's pool, and then made it so that you can make nearby devices believe that they are seeing those wireless networks nearby. So then they query a database and like, hey, where are these networks? I don't have access to GPS. Where's this? Where am I? And the network replies, it's more of a geolocation service by Google or something like that. Will reply, hey, we know where those networks are. They're right here. And then if you look at a map on your phone, it's going to say, hey, you are somewhere in like Palo Alto or wherever.
Does it actually use receive signal strength as well, or is it just giving you like a really rough location, or is it giving you
it does use receive signal strength. So if you have so when you're faking this, if you're making some of the signals stronger than others, for example, you can influence on a more minute level where a phone thinks it is. Now in practice, we tried this out in I think like Glendale, California, and we were able to spoof cell phones in like stairways and like other gross places that like didn't have a lot of ventilation or reception.
Yeah, because like GPS is a pretty weak signal to begin with, so anyone that's like inside, particularly like a big concrete building or something like that, would be susceptible to an attack like that, I think.
Yes, exactly. So if you're indoors, maybe in a giant mall or something like that, or somewhere underground, then you could potentially trick phones into thinking they are somewhere that they're not. And this is really cool because you can also, that can influence the way that photos are tagged that are taken there and uploaded, like things like that.
Does it actually affect like the EXIF data? Or
yeah. So if you take a picture and it's geotagged and you're feeding the device the wrong geolocation, it's going to geotag the photos to the wrong place. And you can basically decide where you want to pretend to be by gathering this information, maybe around your own town, and then finding a place in the town that has a unique set of access points that are available. And you'll find that if you spoof those on a device like an ESP8266, you can trick devices into thinking they're somewhere different.
Yeah.
Now, another way of this being useful is when we all contribute to Wigle.net. I am a huge contributor to that website. Then there is this giant map of publicly available open source geolocation data about where access points are. And also, if you run this on a cell phone, it will also record information like Bluetooth devices and cellular towers. So this has been useful in the past for identifying rogue cell towers. So anytime like a stingray or a cell tower that's going up and down quickly are being used, you can use war driving to detect them, which has been there have been a number of really cool research projects on this. And then when we get into Wi-Fi, there's a number of things you can do as well that are really interesting with the data once you manage to grab it. Yeah. So having the ability to, for example, listen in on nearby devices, calling out for the last network they've connected to. If we can just go to the Wigle.net database and run that name, if it's sufficiently unique, it means we can look up the location of where that phone has just been. So imagine that you go to somewhere that has a fairly unique, maybe it's a business name or something, access point, and then your phone for the next couple days is just trying to connect back to that network because it's the last strong network it connected to, or it could do this for several months after. It's just a behavior of phones that's very common. I, as a hacker, could basically be sniffing the airwaves, see your phone crying out for this network it's connected to in the past, and look up exactly where that is. So if that's your home network, if that's your work network, that could be revealing more information about you than you anticipate. Yeah. And oh yes, so on Michael's screen you can see Wigle.net. One of our goals today is we're going to be war driving a little bit, and then we're going to be trying to convert this into a format that we can upload to Wigle.net. And what Wigle.net does is creates, where is that? New York?
This is Seattle or something?
No, that's New York. Is that New York? No, it's the wrong side of the ocean. Oh.
Yeah, it's San Francisco.
San Francisco. Okay. I've contributed a small amount to this graph.
Yeah, I was going to say, so it creates like a heat map. So each of these dots is actually a unique access point. So you can just like
if you zoom in all the way, it'll actually show you the names.
Yeah, that's why I'm... So like we actually start seeing buildings here.
Yeah, there they are. Yeah, so
I guess network.
So hackers use this information, for example, to unmask employees of a certain business. If I wanted to build a detector that says, "Hey, every employee from this business is going to set off this detector, so I know when someone who works here comes by this point." Okay, super easy to do. I just go over to their place of work, which is a publicly accessible address. I look up what their access point is named. If anybody has war driven, and as you can see, there's great coverage on this open source network.
Yeah.
And then I can basically know the name of the access point that this business is using. So I can create a bunch of fake ones, and if anybody walks by and their phone's like, "Ooh, I recognize this access point," and tries to connect, that lets me know that someone who has worked at this business is passing by, and their phone's just automatically trying to connect. So there's lots of stuff you can do with this information. I think it's super cool because you can also use it to filter really vulnerable networks in your area, or you can use them for device discovery. So you know what story I'm going to tell, right?
No, I was distracted looking at the random access points in the ocean.
Oh, boats. Yeah, well,
it's either boats or like
errors.
airplanes.
Well, no. There's also errors. So there's well, actually that's really funny because it looks like there's a lot going to Hawaii.
Yeah, that's why.
So someone was running like Wigle, but also there's very frequently GPS errors that just very common errors sometimes, which will land you in just the middle of the ocean.
Well, I was gonna say these lines right here, to me, are very indicative of
an error.
Air travel.
No. Well, maybe. Very, very maybe. But more likely, in my opinion, it's a GPS error that is skewed across, that basically is giving the same latitude, for example, and then a slightly different longitude. And
that's possible.
And when that error happens over time, you just get a fat random line in the middle of the ocean. There is definitely it looks like there is definitely some air travel. But I would also say a lot of these are probably errors because I've seen just a huge amount of results in the middle of nowhere.
I'm filtering for the FBI surveillance van.
Yeah, everyone
type
loves
networks.
this network name. So so the story I was going to tell is that you can find certain adult devices that have a Wi-Fi connection. They exist. They're out there.
Isn't there a DEF CON talk about this?
There's a DEF CON talk about this. But these devices have a unique MAC address. So the first half of their MAC address is the same for every single one of these, personal devices. And what's interesting is you can drive around your town and basically run this program, Kismet, on a Raspberry Pi. Today we're going to be using a Raspberry Pi 4, but any Raspberry Pi should work. And I should also mention that we are going to be using the internal card of the Raspberry Pi to do everything today. We don't need to do that. We can also use a wireless network adapter, like this excellent Alpha wireless network adapter, which is actually one of the ones I recommend. This one's really nice. But the Raspberry Pi is able to switch its internal card into monitor mode, meaning we can do a lot of this work on the Pi itself. So if you really want to get started doing this, you get a Pi, you slap in a GPS receiver like this this little one we have here, which is very common and easy to find. It's like, I think...
Do you even need a full Pi? Can you use like a Pi 0W?
You can use a Pi 0W, yes. You absolutely can.
Because this reminds me of like, what was that?
Technically, you can use an ESP8266 to do this. And Alex Lin, one of the researchers we worked with before, has like a functional war driving kit that is just an ESP.
Yeah, this reminds me of the DEF CON talk, like I think it's Warkith or something like that, where they made a war driving collar for their cat. As it roamed around the neighborhood, it would just collect Wi-Fi data.
And they would be able to see where the cat had been. Yeah. Because if they know where that access point is, they can see, okay, my cat's been over here. Like that's what its path was. Yeah, so let's say we have a GPS unit, we stick it into a Raspberry Pi, we start this up, and we go driving around the neighborhood. And then we also know the MAC address range of security cameras, so Nest cameras, things like that. We could basically Ring cameras. We could basically identify every single house that has a Ring. So if we needed to know which houses are recording video footage, that's something right there that would allow, let's say, a reporter or something like that to drive around and basically be able to know every single source of Wi-Fi security camera footage that might be available in a region.
That's kind of creepy.
It is. We could also know every one of these adults' devices that was on in that entire area. So there was a really famous story of someone using Kismet to basically go around and map the location of every single one of these devices. I think it was like in the United States or Australia or something like that. And it was very embarrassing because it's able to actually identify the exact address of every single one of these things. So if you know, and there's a lot of things like this. Police body cameras have a unique MAC address. Like you can find you can find where they've been identified with their hotspot on by basically looking in this database. And if people are driving around and collect some of this information, it will be there and you can spot them.
So on Wigle, can you actually filter for specific devices, or will it only let you filter for networks?
I believe it'll let you, you can, in the advanced search for partial MAC addresses. So that should allow you to look for every single instance of a particular MAC address. And that allows you to find every type of manufacturer. So if you want to do a survey of every HP printer in your neighborhood, or in the United States, you could do that with this database. So for security people, let's say that you want to do a complete wireless audit of all of your infrastructure. You turn this thing on, you walk through all your facilities, and provided you have a good amount of sensor data, the GPS is accurately recording your altitude and stuff, you could find out floor by floor what is vulnerable, what is broadcasting, what kind of footprint you have. And basically you can get an audit of, all right, these are all the wireless devices that are broadcasting. These are the ones that are supposed to be here. These are the ones that we don't know what they are. And these are the ones that are actually a threat because they're either something like an open printer on the second floor. It's like, oh, hackers will never get to the second floor. It's like, well, maybe they will. You wouldn't know necessarily that this printer happens to have its access point on. I went to a doctor's office that had a security camera that somebody plugged in, and it had an open access point where if you downloaded the app for the camera, just allowed you instant access to the camera. So you could, from another room, from outside, you could listen in on all of the insurance conversations over the phone, all of the prescription. Basically, they bugged the front desk in a way that anybody could access. And I had to go and be like, hi, excuse me, like you only partially set up your security camera.
Yeah, that's a HIPAA violation
it
right
happens
there.
all of the time. So that is why these are so valuable. You can basically go through an area and instantly find out, oh, wow, I didn't know this device was running a WEP network Wi-Fi access point that anybody could crack. It's like, this is a huge threat. Like, you can identify every vulnerable access point in your city if you wanted to. You can identify every open access point in your city. You can identify, so basically if you're looking for free or easy sources of internet, it would be very easy to do that. This basically lets you do a complete walkthrough and footprint of your entire organization, like all in one go when it comes to wireless devices, which I think is fantastic and cool. And it even is possible to do things like Bluetooth devices as well. We're not going to get too much into that today, but there's a lot of Bluetooth devices that could also present a threat. And I think that hands down, this is the easiest way to be able to go through and audit your organization or audit an area for, vulnerable wireless devices or devices that aren't supposed to be there at all.
Yeah, and do you need like an Ubertooth or anything special to do the Bluetooth sort of stuff?
This has built-in Bluetooth as well. I haven't fully tested that it's working, but I believe it is. And I saw that it appeared as a source when we tried this the first time, so maybe I'll try flipping it on today and see if it works. It might crash it, who knows? Now, there is one bug that I've noticed. This will probably be resolved at some point, but I've noticed that when we run this, it is really difficult to get the wireless card to start back up and connect to Wi-Fi until we reboot after. So one limitation so far on this has been, I've noticed that when Kismet puts the Wi-Fi card in the Raspberry Pi into monitor mode, then it's really difficult to get it back. So just have to reboot. The other thing to note is this worked on Kali Linux on the Raspberry Pi. It does not work on Raspbian. It does not work on any other operating system that you might put on it, because there's a special hack that the security community came up with for making the Raspberry Pi be able to put its card into monitor mode. Normally that is not possible. So if you're not using a build of the Raspberry Pi that has that special patch applied to it, which Kali Linux does have that patch, then you're not going to be able to do this. So you do pretty much need Kali Linux at this point, or you need to be able to install the Nextmon patch, which honestly it's easier to just install Kali.
And if you need a guide on that, then we've done several guides on the Nullbyte channel on how to do that.
Right.
Did we do a live stream on booting Kali Pi? I feel like, we've done a live stream on Kali Pi.
So we're going to be using the 64-bit version of Kali Linux for the Raspberry Pi today. So this is super updated. It's like the newest version. And I think that right now there's a couple little bugs that are still a little bit annoying, like that one I mentioned. There's a couple of things to get used to if you haven't been in Kali Linux for a while, but we're going to go through them and it should be pretty easy. Yeah. I also think this is going to be really useful because for getting into Wi-Fi hacking, for getting into taking a small project and turning it into something really cool and interesting, this is really great because you're recording your own sensor data. You can also convert this data into other formats, and that's what we're going to be doing today. We're going to take this Kismet database, which is actually like SQLite 3, I think, database, or SQLite 3. Whatever. It's a database. So we need to convert it into another format before we can upload it to wigle.net. We're going to convert it into a CSV file, which we can also look at in other ways to get more information. So there's lots of things we can do here with the data as soon as we gather it. Of course, our friend Alex Lynn imports it into Jupyter Notebook and starts slicing and dicing it to look for relationships and patterns. So if you're kind of into signals intelligence and you know a little bit of Python, this could be something that allows you to create like a friend detector that basically like knows when a certain friend is nearby, or anything you really want to do with this, you can tweak it to get it to work, provided you know a little bit of Python and you are able to work with the data that it produces.
This reminds me of a harebrained scheme I had once with the Raspberry Pi. I wanted to like contact the local like garbage company and just be like, oh yes, I have like this environmental monitor that I need to put on all your trucks for a school project, and just have them scan the entire city once a week for me
and just continually update the location of like every device in the city. That's brilliant. That's brilliant.
I never went through with it, but
I imagine some garbage people are probably doing that.
Yeah, no, for sure. Like there's some sketchy stuff like that going on somewhere that we just don't know about.
All right, well, let's jump into the Raspberry Pi 4. So in order to do this...
Pi screen?
Yep, Pi screen. Okay. So in order to do this, you're first going to need to flash... Let me move my... There we go. You're first going to need to flash a Raspberry Pi with the 64-bit version of Kali Linux. And you can grab that from the Kali Linux website. It's like kali.net or something like that.
Yeah, just Google Kali
Offensive
Linux.
security, they're great.
Yeah.
So when we're logging into Kali Linux on the new version, it's not root and tour anymore. It's Kali to log in.
Yeah, that confused me. It's been root tour for so long.
Yeah, since
I was trying to log in for like 5 minutes.
Yeah, it's very confusing. Okay, so now we're in Kali Linux. We can tell by this like sexy dragon here. And what we're gonna do is press the Windows key, which now is just the GUI key, and we're gonna open a terminal window. All right, so the old version of Kismet was command line only. This needs to be so much bigger for me to have any.
I was gonna say I have 20/20 vision, and I can barely see.
Bigger.
We have a screen very far away for this one.
Okay, cool. All right, that's somewhat better. It's like old people size.
Yeah.
Here we go. Okay. So what we need to do is a couple things. First, we have a GPS unit plugged into this Raspberry Pi. So we need to locate it, and then we need to set this up to use the GPS. Because what we're essentially doing here is we're taking the wireless card on the Raspberry Pi, and we're using it to record the signal strength and then all of the information about nearby devices that are broadcasting packets. But we're tying it to a GPS signal as well that tells us exactly where we are. So as we move, we use our GPS signal and the signal strength of other nearby devices to judge their relative location. So if we're going in a straight line and we observe, this device getting stronger, and then suddenly it starts getting weaker, we'll basically be able to figure out roughly where the actual access point is. So it's called trilateralization. It's basically the way that we're going to use the GPS signal and the Wi-Fi signal together to try to locate devices nearby as we move around. So the more different readings we get, the better the positional accuracy will be for an access point we're trying to geolocate. So if we go completely around in a circle, we're probably going to be able to figure out more or less exactly where it is. But if we just happen to detect it a couple times while traveling in a straight line, we're only going to get a rough approximation of where it is.
Yeah. If you're wondering how that works, you're actually just like drawing a circle from each like GPS point with like the received signal strength and where they all overlap is roughly where it's going to be.
Exactly.
With some error in there.
Right. And this is a continuous process. So the end result that it spits out should be a rough estimation based on all the contacts we've had with that access point. So, okay, the first thing we need to do is actually find it. So let's try to locate devices that are plugged into the serial port by doing a D-message. So this will show us any devices that are plugged in will generate a message here or an alert. We'll pipe it into grep, which will search through that, and then type TTY, because it's going to be TTY USB something. So if we just type dmessage, we'd get a big, huge list of information. By piping it into grep, which is a search function, we can basically search for any lines that contain the word or the partial string TTY. So here we can see at the very bottom that the converter is now attached to TTY USB 0. So what that means is we actually have this plugged in, and the location is TTY USB 0. Okay, so what we need to do is start a GPS server in order to actually be able to figure out where we are and serve up this GPS information to somewhere. Just having it plugged in doesn't actually help us very much. We need to have something started on our device that's taking that information and making it available for other programs that want to use it, in our case, Kismet.
Yeah.
So we're going to use the program GPSD, and that's a very simple install on Kali Linux. It's just sudo apt install GPSD and Kali's password. And the GPSD package also includes a couple test things such as CGPS, which we're going to use to confirm that our GPS is actually working. Although I think we're going to try to blur out our actual GPS.
Yeah, I was going to say we might not even get any
creeps.
because we're in a basement.
Just because we probably won't even be able to get a fix.
Yeah.
All right, so we're going to go ahead. So you can see that I have GPSD installed. I can type man GPSD if I want to see more details about it. And yes, it's an interface daemon for GPS receivers. It'll basically continuously update. I'm sorry, Michael, am I boring you?
No.
That's great. So it's going to continuously update the GPS feed and provide it in an easy, digestible format for other Linux programs. Cool stuff. So we're going to type GPSD, sudo GPSD, and then /dev /tty USB 0. And if you add like USB 1 or USB 2 instead, then this is where you type, TTY USB 1 or 2. So /dev is where the serial ports are on a Linux system. So we're basically saying, hey, GPSD, start and point yourself towards the serial port. That's where the data is.
Cool.
Look at that, no feedback. Isn't that helpful? Thanks, GPSD. So we have no idea if this worked or not. But if we type CGPS...
It just disappeared into the black hole of Linux.
We should see some junk happening on the bottom, and then on this side right here, we should start to see satellites start to check in as we receive them. Now, there is a window, so I expect we are going to get some like Russian satellite like creeping in through the side. So on this side, you can see right now we have no fix. But as soon as this becomes blurry, it means that we got a fix and we now have to blur it.
Yeah, so GPS can take like 30 seconds to get a fix.
There we are. Okay, so now you can see we have no fix.
I'm surprised we have
So I'm going to... But here we can see we have multiple satellites that have checked in. Yeah. And if I let this run, then we're going to get us fixed in 11 seconds. But I'm going to cancel it. So Hey, we got it. We didn't have to blur it. All right, cool.
Yeah.
So that's as soon as you see satellites on the right side and it starts like counting down to a fix, then you're good. Today we're going to use a fixed location, which is actually our real location. So if you really want to track us, then we'll give you our GPS location and you can do it. We don't care. Mm-hmm. So, all right. So we've started up our GPS. We now have a GPS server running that's serving it. Now we have to configure Kismet. So I have some thoughts about this. Kismet used to be a command line utility that allowed you to pass arguments. So for a beginner, that just means, doing Kismet --help, and it's going to tell you, oh, these are all the options, like, pass, -C to select the interface, like, and pass all this other stuff, and it'll work. Look at how short this file is. There's, like, not that many options at all. Because everything is configured through this configuration file. Yeah. So for beginners, I often teach them about positional arguments when running a program. I teach them about all this stuff. I don't usually teach them about configuration files because I find it tedious. And honestly, they get, unless it's really well documented, which fortunately this is pretty well documented, they get all wide-eyed about oh my God, this is just tons of data. What does this mean? When would I ever use this? I really like programs that make it super simple for people to set up. I'm not saying that this isn't, but I'm not saying that it isn't. Yeah. I will say that I had to sit down with my friend who hasn't used Kismet before, and what would have been a process of just go ahead, run Kismet -C, and then use these different prompts, suddenly became okay, dig into this weird text file. They're what format is this? I was I don't know. Don't ask questions. So it's it became a much harder, or at least less fun experience for beginners who hadn't dug around in a configuration file before. So I know I'm talking a bunch of smack about this. You're going to see that it's actually pretty easy, but it's not, I would say, intuitive for a beginner who's used to using Linux programs that just have standard arguments. The best this can really do for arguments is just allowing you to say which network adapter we're using. And today we have a couple network adapters. We have one external one, which is a Panda wireless network adapter that's plugged in. And we also have the internal card. And if I go over here, then we should be able, I think it's,
if you have multiple,
here we go. So we can see I have multiple cards, and you can see it gives us information about the chipset, so we know which is which. So this is the one that's the Broadcom one that has like Bluetooth as well. That is the internal card. And then this one down here is the Panda wireless card, and I can tell that from the chipset.
I was going to ask, so what reason would you want to have multiple Wi-Fi card?
So if you want to be able, so if you are connected to a Wi-Fi network from the Raspberry Pi, and then let's say you connect on your phone to the same Wi-Fi network, or even you create a hotspot on your phone and connect the Raspberry Pi to it, whatever. Then you use the second card on the Raspberry Pi, the one you plugged in, to do the Wi-Fi scanning with Kismet. Kismet will serve up a Wi-Fi interface, and you can go to that interface on your phone if you're on the same network. So you can remotely look at all this information and even control some parts of the scan from your phone or from another device using this web interface, even though it's hosted on the Raspberry Pi.
That's I just thought of something very devious. If you did do this on a Pi 0W and just put it on your dog's collar, you could just be walking your dog and war walking basically very easily, and no one would know what's going on. You're just looking at your phone while.
Of course, you could also on that same phone be running Wigle Wi-Fi in the background.
That's true. I mean, that would be a simpler solution.
I mean, I think it would be if you let your dog off the leash and then it goes somewhere it's not supposed to, and you're oh, sorry, and then you're just collect the scan.
Yeah, but additionally, if you do have more adapters, could you possibly have them scan on different channels simultaneously to get a more thorough scan?
So one thing is, if you are scanning on one channel, then you're missing all the other channels. So if you're channel hopping, and that's one thing we'll take a look at, then you're going to be jumping around to different channels. And the good news is, you get a pretty broad survey of all the devices that are out there. But the bad news is, you also aren't really getting a full representation of anything that's happening on one particular channel. So if you wanted to stick in, I don't know, really 3 is probably enough to get most of the traffic, because a lot of these channels actually overlap. 1, 6, and 11 are the only channels that don't overlap. So you'll frequently just need to monitor those ones to really get most of the traffic. But if you have 3 wireless network adapters, you're monitoring those 3 channels, you have a much better chance of getting all of the traffic than you would if you had a single network adapter just skipping between all of those. Because they're only going to be on that channel 1/11th of the time. So everything that's happening in that other 10 fractions of whatever a second or whatever else, it's going to be missing everything that's happening on that channel. So.
And with Kismet, will it just log like the devices and MAC address and that level of information, or will it also like passively capture handshakes and do stuff like that as well? Or is that more like Wireshark?
It's going to capture everything, but that's more Wireshark.
Yeah, okay.
I believe you could probably do that, but I honestly find the new version of Kismet to be super confusing. Gotcha. So while there's like API access and all this other stuff that's great, the documentation for how to use it, I'm not gonna comment on it. I'm just gonna say that it's not the way I would have tried to make the project accessible for beginners. But it is still very powerful. I guess that's the point. So let's go ahead and try it. I'm going to. All right. So to install Kismet, it's a very simple sudo apt.
You did so do I.
Kismet. This keyboard's tiny and weird. All right, so it's already installed. That's how simple it is to install on Kali Linux. And now it used to install the old version by default. As soon as you apt update, it should install the new version. And the new version is not the same. So, all right, we need to go into the configuration file for Kismet and change some stuff for the GPS to be recognized. So let's do that first, because now the new Kismet is controlled mostly by this configuration file. So I'm going to nano.
What, you don't want to use Vim?
Stop. Don't provoke conflict on my show. We're going to go to... Oh, wait. Actually, I'm going to cheat.
Wow.
Crap.
Much lazy.
So we're looking for a config file. Here we go. All right. So we're gonna, so it's sudo nano /etc. Oh, I was right. /etc/kismet/kismet.config. I was trying to autocomplete it, and it wasn't autocompleting, and it was freaking me out. But I guess I was just being impatient. Of course it's not found, you stupid computer. I didn't mean to run it. Whatever. Sudo nano. It's because I hate typing on this keyboard. /etc/kis. There we go. Kismet. Okay, that's good. /kismet.config.
Cool.
Okay, so when I press enter, we're going into our Michael's favorite text editor, Nano. And
hey, at least it's very well commented.
Yeah, and I will say at least it's very well commented. So everything with a little hashtag in front of it has been commented out. And everything that is in white is basically going to be red. Everything in blue is not going to be red. So we can see that there's good documentation that explains like what each one of these is. I'm going to scroll through all of them.
Oh, wow. This is a long doc.
Right? This is ridiculous. I'm sorry.
Yeah,
this is for a beginner. Like, they're going to be
that's
like,
going to be a little overwhelming.
They're going to be like, what does this even mean? Yeah. But I know what it means because I spent the time to read through a huge document list and a bunch of other things that were just on.
Yeah, normally I like
All right, GPS configuration. Yeah. Oh my God, it took forever to get here. All right, so we are normally going to use GPSD. Here it is right here. So if we just get rid of this pound symbol right here, then will read this line. But instead, we are going to use our actual location. So we're going to, since we're in a basement and we're not getting great reception, we're going to put in our location, which is of course high orbit over Yolo, California. Although I will say that we made a small error. This is not feet. This is meters. So yeah, so we were like over 100 miles over Yolo, California, which is not our true location. We're actually in low Earth orbit. So where does low Earth orbit start? Well, we can estimate, right?
Sure, we can estimate.
So yeah, just look it up real quick. Low, and I need it in meters, please.
Orbit altitude.
All right, so we're gonna start.
It's 160 kilometers, so 160,000.
160,000.
Yeah.
All right, so now we're 160,000 meters over Yolo, California, our low Earth space station that we broadcast this from. I hope you guys like it. The lights are really nice. I think it's our favorite addition so far, aside from the oxygen.
You got all squiggly stuff, and then I'm just like straight lines.
Yeah. Well. Yeah. All right. So we've set a virtual location, but you guys should, if you have a GPS receiver, then just get rid of this around GPSD. It should look like that. But I'm not going to use that. We're going to use our virtualized location. So I'm going to press Control X, Y to save it, Enter. And if you don't use sudo, by the way, it won't let you save it. It will let you open it, but won't let you save it. Very annoying. Okay, so now we've set up Kismet so that it should take our in our case, our virtual location, but it should take our GPSD location if we've commented or if we've gotten rid of the pound sign in front of the GPSD line. Okay, so as soon as we start Kismet, it's going to pull in our GPS data and we're going to be able to use it. Now we need to put our card into monitor mode. So if I type ifconfig in Kali Linux, guess what happens? It pretends like it doesn't understand me.
Why?
Stupid computer. Because it doesn't trust me. So if I type sudo exclamation point, it has tons to say.
Okay.
Right. It's just like, for beginners, like sometimes it's confusing.
Pro tip, if you get permission denied error.
Yeah, just run it as sudo, just sudo it. So here we can see we have two wireless cards. We have the internal card and we have WLAN 1, which is the card that we plugged in. So if we want to use the internal one, do you guys want us to use the internal one? Sure, we'll do it. We're going to put the internal card into monitor mode. So sudo sudo airmon ng
you misspelled it.
Oh god, I hate this keyboard.
Yeah.
Airmon.
You misspelled.
How is this?
Okay, go slowly. Space air. Yes. I know this is very difficult.
Yeah, I would have you do it, but you don't know how to talk to computers. All right. So we're putting this into monitor mode. If I type sudo ifconfig again, then you can see that it's changed its name. And it's now been put into wireless monitor mode. And you can tell that because it says mon at the end. If I type IPA, this keyboard, IPA, then you can see it's in broadcast, multicast, low up. I want to see if it says it's in monitor mode. Let's do iwconfig. Sudo.
Although that doesn't even give you like a permission denied error. It's just like command doesn't exist.
Sudo.
Yeah. You have it installed?
There we go. I have no idea. Okay, so mode manage, access point not associated. So because we're using the internal card, I'm a little bit... Oh wait, no. WLAN 1. It's funny that this still knows it as WLAN 1, even though the name officially has been changed. So that's interesting. It thinks it's still connected to an access point. Whatever. So I'm not too worried. If I wanted to check it out, I can do sudo arrow dump ng WLAN 1 mon. Wait.
Did it take it out of monitor mode?
Oh, no, I did. Sorry, I did the internal card. I'm done.
Yeah. I thought this was...
It's WLAN 0 mon.
Oh.
Okay, there we go. So we can see that it's able to see stuff in monitor mode. We have it working. So let's do Kismet now. So we'll do sudo... Well, actually, we don't need to sudo Kismet. We can just do Kismet. And actually, let me remove my old ones. So if I type... Well, first, let me go to the desktop, cd desktop. That's where we're going to put all of our files. I'll type ls. We can see there's a Kismet file already in there. So I'm going to rm Kismet, and we can see that now there's nothing there. So we're starting from a clean start. Okay, so we're going to do Kismet, and then we're going to do -c for, that's the capture source, and it's going to be WLAN 0 mon.
So can you just chain multiple capture sources together when you have...
Yes, you can.
Okay,
Yeah,
cool.
you can. So I'm going to press enter. Hopefully this works. And we get all this stuff. So we can see that it's successfully detecting stuff. That's great. But how do we actually see this? Well, I'm going to right mouse click here, open link. It's going to open a browser link. And we should, if it works, sometimes I have to do it twice. Nope, there we go. It should take us to Kismet. So the first time we do this, it's going to ask us for a password. Oh my God, this is so small on my screen.
Yeah.
There, bigger, bigger, bigger. Okay, cool. So, all right, I can barely, there we go. So I can barely read this now, but okay. So we have now a handy web interface that allows us to get to this information. And this is really a rich source of data. I really like this because it lets us drill down on any particular network. So if I want to click on this network here, I can start accessing information about what channels it's transmitting on. I can see relationships with other Wi-Fi devices. So what I love about this interface is that it intuitively shows you exactly what this device is doing, what other devices it's interacted with. I can see if it's broadcasting other SSIDs, and then here I can see Oh yeah, associated clients, and that actually updated while I was looking at it. So here I can see these are the devices that are connected to this network. I can click on them. I can get information about their manufacturer. I can find out who made them. I can get other information about this device in a breakout window here. Now suddenly I'm tracking this client. I can go down. I can see if this client has permission to connect to other Wi-Fi networks. Is it calling out for other Wi-Fi networks? You can see that it is a client of 2 different networks. So very quickly, I've been able to identify a network, find a client on that network, and then find out that that client has permission to access another network beside that network. So really quickly, we're able to do wireless signals intelligence and start figuring out who's connected to what else they're able to connect to, and details like maybe them calling out for another network.
Yeah, is that other network just like the other access point for this network?
Yes. So in this case, we have what's called an extended service set. So we have 2 access points that are broadcasting the same name but have different MAC addresses.
Yeah.
So the reason for that is that if you have a large area that basically has a lot of different coverage that's needed, you might need to extend that. So like universities are very frequent,
they're going to have way more than 2.
Yeah, like a student will connect to a Wi-Fi network, and then all the buildings on campus will basically be broadcasting the same network name. So this is a way we can identify things like extended service sets and that sort of thing.
Cool.
Yeah. Okay, so what we're going to do next is, we can still, let's take a look at some of the options here. So the configuration file, by and large, is the thing that's going to give us the most ability to change stuff in Kismet. But there is some live stuff we can do. So if I click here, then I can see we have the option to go through different data sources. And this is where I might try to turn like the Bluetooth on.
And so this is the same monitor that you would see in your phone, and the control you would be able to have on your phone?
Yes. And in fact, we can even try to do this on your computer shortly.
Yeah.
Let me try to turn on the Bluetooth.
So it's generating its own access point right now, or is it doing this on a network?
It is on the network. So in order to go through the steps of connecting to this, I'm going to create
you just do your thing. I'll just hack into your
let me give it to you, because you don't know what port it's on.
Oh.
Okay, so
well, I was just going to ping the network.
Let me make this big. So if you want to connect to the Raspberry Pi and see this interface on a friendlier device, maybe a larger device, then here you can see that we want to use you connected this via Ethernet, right?
Yeah.
So you want to connect to 192.168.1.2.13.
213.
And the port you're going to connect on, let me know when you're ready.
Hold up. And then the port
2501.
2501? Okay.
Cool, let's switch to your screen.
Yeah.
Okay, so Michael's now connecting over the local internet to the Raspberry Pi. So the password is Cali.
Okay.
And then log in.
Yeah, it didn't want to accept enter.
Cool. So Michael now has access to all the same information that we were looking at on the Raspberry Pi. So if we were running this Raspberry Pi headless and it's supposed to automatically connect to, let's say, our phone's access point, we basically connect any device to our phone's access point and access the information coming in from Kismet on the Raspberry Pi.
Yeah. I could even think like if you're like running like a smart home or something, how you could have this running and then like detect when people come and go from the house.
Yeah, absolutely.
And then do all automations based on like who's home and stuff.
So click on the menu, hamburger, I guess, on the left side.
That has to be the official name.
Yeah, it's a hamburger. I've had to design UI UX menus before. It's a hamburger. Go to data sources.
Okay.
And then I believe it'll don't click on anything yet. I didn't say click on anything. All right, so we're going to go to Bluetooth. Do click on Bluetooth.
Linux Blue.
Yeah. So click on enable source and let's see if it works.
Da-da-da!
Hey, we're detecting Bluetooth devices. So we can geolocate Bluetooth devices too. You know what this means? Cars. For some reason, it's really easy to just like track cars via Bluetooth. So if you are doing war driving, then you can probably identify vehicles using this exact same method.
Yeah.
So
I have my phone running Bluetooth.
WLAN 0, WLAN 1. Yeah, so we plugged in just to see, we plugged in an RTL SDR to see, which is a software-defined radio that's capable of seeing airplanes, which we covered on a previous stream.
Yeah.
And so you can actually use this with Kismet. However, we aren't running an RTL SDR server, so we're not serving up the information the way we are our GPS information. So we're probably not going to be able to access the interface. I was just kind of curious to see if it just popped up.
Yeah, it doesn't automatically populate. There might be the driver isn't installed for that RTL SDR, but it's a pretty common one, so it's probably just a server thing. So then if we wanted to see this Bluetooth data, like I can see like 4 here, like how do you look at that?
192.168. What was the
213 and then 2501. Funny enough, I did not actually see this device on the Fing scan.
Interesting.
Maybe.
All right, let's switch over to my screen. All right, I am now also in the it's so crowded in here.
Oh yeah, and I was gonna say you forgot to have me do that.
Yeah, so we're all in the Raspberry Pi now. All of us are in the Raspberry Pi. So we can see information about the type of device. So if we want to see Bluetooth devices, look at this. We got a Bluetooth device. It's really, we can leave notes here about the device. We can try to derive the manufacturer. This is really cool because a lot of things will make it really easy to see the manufacturer. If I want to go to the options here, we can go to the general settings. And this is where we can do things like customize what information we're showing. So we can show the MAC address and the manufacturer. I want to show all that information. So I'm going to save these settings. And now in the column, it should show the manufacturer. So if I want to do some sorting by manufacturer, we can start adjusting that as well. In the row highlighting, I can say, hey, I want to see Bluetooth devices with a new color. I can say I want to see Wi-Fi devices with a different color. Save these changes, and that should visually differentiate these now. See, now we can see blue is blue.
Oh, that is really helpful.
And then for units and measurements, of course, I'm switching all of these to imperial because I'm not a communist. And then, sorry, Stefan. Oh, yeah, save changes.
Oh, this is pretty cool.
There's plugins that can be loaded, which we're not doing any today. And then we can change the login and password. So I've customized this a bit now. I'm going to exit. And we can see that my screen looks very different. We now have the ability, we now have the ability to see nothing.
I was going to switch over to my screen real quick.
Sure.
Just because I just realized you can check the Wi-Fi channels. So this is a really easy way if you're setting up a Wi-Fi network to do a site survey and be like, okay, this is how I need to set up, especially if you're doing multiple access points and they're going to be on different channels and stuff like that. That seems like a very powerful way to look into that.
Yeah.
I'll go back to your screen.
Yeah, so there's lots of cool stuff here. Right now, over here, we can see there's no alerts to show. But if we were to start attacking a Wi-Fi network or doing some sketchy stuff, it would detect it. And it would basically alert us that there's a couple different behaviors that are detected here. One of them is access points that change their SSID frequently. So if it's like a device that's like got the same MAC address, but it keeps like broadcasting different names, like that is considered to be suspicious because it might be phishing. If there's deauthing detected on the network, it will warn you about that. So it just like basically shows you a number of different things that could be happening on the network.
So this is the ADSB stuff you were talking about?
Yes. So there's also a section for ADSB Live. So you can see all this interesting information. Again, I think we need to set up a server in order to be seeing this information.
Yeah, we did a live stream previously on how you can look at this stuff with the Raspberry Pi, but we didn't actually talk about Kismet. So we can look into that in the future.
So I have an RTL SDR that's on its way, and it should be here in a couple days. So because I've lost 2 of them so far already. So if you guys are interested, please let us know, and we'll start showing you how you can detect airplanes and what this looks like both in Kismet and then through some other interfaces.
But there's other stuff you can do with RTL SDRs as well. Like you can, I think you can look at like other IoT networks like LoRa and can this look at like Zigbee and Z-Wave?
I don't know.
Because I think those are 2.4.
Yeah,
at least one of them.
Ask the Kismet guys, but not without special equipment, I believe.
Yeah.
All right, so if we go back to my screen, we can see a brief survey of all of the access points that are nearby, the length of the access point last seen, the encryption that's involved, how many devices are probing for them, how many are responding, and then how many SSIDs are advertising. So here we can see this one has 2 access points that are advertising the same access point, or the same access point name, or SSID. But yeah, I love this view. I think it's super cool. This is all in a database. We can search. So here on the side we have manufacturer, which we can separate by. So we can scroll through and we can see that well, a lot of them are unknown. But Raspberry Pi. So here we've got Raspberry Pi on the network. We can see the two, well, at least one of the wireless cards that the Raspberry Pi is using. So this is really cool that we can see the Pi is like seeing itself connecting to Wi-Fi.
That's weird because it has multiple antennas.
Yep. So we can see that it is a client of this Wi-Fi network. So that's really funny. I think that's cool. Okay, so how do we actually? Oh wait, Pixel 2 XL.
Yeah, that's me.
Hey, look, it's Michael's phone. So we've detected Michael's phone.
Well, speaking of Michael's phone, we need to wrap up soon.
Oh yeah, cool. So all right, we have all this great data. How is that speaking of Michael's phone? All right, let's switch back over to the Raspberry Pi.
Yeah.
Okay, so we've recorded all this great information. It's wonderful. I'm going to press Control-C and we're going to shut it down. And now
No.
errors abound. All of us get kicked out of our precious Kismet. Yes.
Sad.
But the data's been saved. So if I type ls, we can see this giant useless file. And again, this is the database file. So if you were trying to, oh my God, want to see something funny? Let's cat this file. Let's see what's in it.
No, please.
Yeah, no, let's do it. Hey, look at all this useful information.
Also, pro tip, if you need to look like an expert hacker for your friend real quick,
if you
cat a file.
Cat a binary file. If anytime I need to impress someone and be like, hold on, let me hack this, I just cat a binary file and it like dings a whole bunch and all this like inscrutable text like scrolls across. I'm just like, perfect. I don't even know what happened. It like not only did that, but it like left me with a bunch of like nonsense on the screen. So don't do that. But as you can see, like we can't do anything with this file as is. Like it doesn't, it's not useful. So how do we actually upload this to Kismet or like work with it? Okay, or to a Wigle Wi-Fi or work with it. Okay, so we got to do this lame command, which again, I think should just be an argument to Kismet, but whatever. So this is included by default with Kismet. So I'm gonna also make sure I don't mess this up by cheating again.
You little
All right,
cheater.
so we're using Kismet DB to Wigle CSV. That is the command. I think, again, it is lame, but that's all right. So I'm going to copy this, paste it, clear, and let's go through what this is doing. So Kismet DB to Wigle CSV, as you might imagine, takes a Kismet database file and converts it to a Wigle CSV file. There's two arguments. There's the in file, which is going to be, basically the Kismet capture we just did. So I'll need to adjust this to reflect the new name. And then the out file, which, I'll have to adjust this to reflect a new name because it just says Michael Veronis and no one wants to see that. So I'm going to say,
you saved my...
hacking with friends. All right. So that's going to be the name of our CSV file. Our in file is going to be Kismet something. It's going to be, Kismet, this big ass file name. And then what we're hoping for is for, as soon as we type ls, to see this hacking with friends or hacking with friends CSV file appear. And that will be derived from the database.
Computers think.
Computers thinking. And
Thinking a little more.
was it really that much? I guess I haven't.
We left this running for a bit.
I did let it run for a while, and I did turn on Bluetooth too, so maybe it doesn't like that.
Yeah.
But okay, so the computer's going to continue to think. Oh, and it just finished right as I was like switching. I was getting frustrated. Okay, so let's type ls and hackinwithfriends.csv. Okay, so there we go. We've managed to make a CSV file out of this. Now I'm going to use a Python program called TapView to just look at the CSV file.
No, I think part of that processing time was just because we're running this on the Pi.
Of course.
Yeah.
All right, so TapView is a program that lets us go through CSV files really easily. You can just do pip install of TapView if you want to. So we can see our columns are the MAC address, the SSID, the authorization mode, first seen channel, and the received signal strength. So that lets us know how strong it is. And then our current latitude, take this down, it's where we really live. And then the current longitude, again, feel free to send us packages in space. And then the altitude. This is our current altitude, which is 160,000 meters. So make sure that you specify, because if you miss that, then you will create space junk. And then the accuracy in meters, 0. We can see also the type. So if we wanted to filter this, we can see Wi-Fi, Wi-Fi, Wi-Fi. But if I scroll down far enough, I should start to see Bluetooth too. And this, this is not going to change for a while because we have lots of Wi-Fi detections. But here we can see the, basically all the information we gathered. Multiple different observations of each one. So this is enough information for Wigle.net to start making guesses about where all these are. And we can just directly upload this Wigle CSV file to Wigle.net. And boom, we've done our war driving. We can slice and dice through the data. We can also take this information and we can make it so that if we want to drag it into, for example, Jupyter Notebook, we can look for unique relationships where if someone was, creeping on us, or if there was a certain manufacturer of a device that we think is creepy and scary and we don't want it near our house, like, I don't know, maybe a police body camera, then we could literally set an alert for when we see that and be like, all right, these are the times when a device of this MAC address was in range. So it's really, really cool that you can say, how many times did I pass by a Nest door camera today?
Yeah.
Or how many times, did I detect like a device with really old encryption, with WEP encryption, where anybody could hack into that network? This makes it really easy to not only capture the information, but then export it into a CSV format and then just import it directly into something like a data analysis program like, Jupyter Notebook. So lots of potential. Lots of cool raw data, and even for beginners, you can upload this to Wigle Wi-Fi, and you don't need to be a data scientist to play around with this information and make cool discoveries. Yeah,
for sure. And I like the idea that you can just like put this on a Pi and just like SSH into it, start it up, and then have your phone open.
SSH?
You don't.
You can set this up as a bash script. So as soon as the Pi turns on, it starts serving this up as a web page and connects to your phone's hotspot. So basically, you just plug this in, then on your phone, log into the hotspot. And you would be able to see the menu that we were showing you and basically control the scan. You can set what channel it's on. You can set if it's doing channel hopping. All that stuff.
I think it would be really cool too to just like plop this in your car and just have a boot up thing where it automatically runs Kismet every time you start up your car and drive somewhere.
Yes, but it will. So the only downside to this is you need to find a way to have it gracefully shut down when you turn your car off. Because if you turn off your Raspberry Pi without shutting it down, it will frequently corrupt the SD card, and you'll have the micro SD card.
Yeah.
And you'll have to completely reflash it and lose all the data. Yeah.
So if you were pursuing a project like that, there's a Pi hat called Pi Juice, and it's basically a UPS, an uninterruptible power supply for the Raspberry Pi. So it actually has a built-in function. Once it loses power, it has a li-poly battery that it can run on for a bit and then gracefully shut down.
Oh, yeah. So lots of cool stuff. Hopefully you guys have been inspired to do something with all this cool information. If you have any great ideas for this or other episodes, also hit us up and let us know. If you like this, we can also do an ADSB episode on tracking airplanes in Kismet. I think Kismet's a really great tool in spite of all the smack that I've talked today. I think it's for signals intelligence, one of the best ways you can gather your own data and start doing some really cool scientific studies of Wi-Fi or other wireless network phenomena.
Yeah, we can definitely do a more advanced version of this with some SDR stuff going on.
And Bluetooth.
Yeah, and Bluetooth.
Yeah. So we can also talk about the kinds of alerts that Kismet can show. So if you're under attack and you want to be able to prove it, this is a good way to be able to detect suspicious device behavior on your network without investing in something really like some expensive intrusion detection.
I definitely have some project ideas for this around the house, just like as alarms for when someone's de-authing or like when someone comes home. Or, you could detect, like, when suspicious people are in your neighborhood. With
so we could even do something that's just, detecting attacks with Kismet and basically run some attacks and show you guys what it looks like on Kismet or another IDS when we're trying to basically detect what's going on and what the signs are.
Yeah, we've looked at that in Wireshark in the past.
Yeah.
But it would be cool to see that in Kismet. And then also, like, if there's a Kismet API, then how we could integrate that to, like, send you a text when someone starts de-authing on the network or something. Because with a Pi, you could like Ethernet in and stuff like that. Because like we've covered the de-auth detector in a previous live stream, but one of the limitations for that is like you have to like blink an LED or you need to connect it to something else. But
this can be dedicated on all the time, or you can just slap in a second network adapter and be connected over Wi-Fi. It's just super easy to treat these as more modular, full Linux systems because they just have way more resources and they can be much more flexible than a microcontroller.
And I was gonna say, and using like a Pi Zero W and you wouldn't even need an adapter. You'd literally just need to plug in a power supply if it's sitting still, and then GPS if you wanted to.
And then also like an Ethernet adapter if you wanted to.
If you wanted to Ethernet it in, So but still, that would be like for less than $25, you could have something up and running.
Yeah.
Which is crazy.
Which is very cool. All right, that's all the time we have for today. I want to give a big shout out to Veronis for helping us make this show a thing. So if you like this show, make sure to go to youtube.com/securityforward, that's securityfwd. Check out this and other saved episodes. And also check out the PowerShell Attack Labs. It's a great example of how hackers like us can break into a network and still get caught, even if we are sophisticated, using Veronis's advanced tools. And if you guys are interested in PowerShell and Active Directory, you can also check out some of the other free great Veronis resources, like the AD PowerShell Workshop, which is, in my opinion, probably the best way of getting started scripting in Active Directory with PowerShell, which for people that do a lot of PowerShell Windows stuff is really helpful, sometimes hard to find information. So check that out if you like this stuff. Hopefully we will see you guys next time. We stream every Tuesday and Friday. So we will see you guys on our next stream. Thanks for hanging out with us, and yeah, see you next time.